Welcome to the second video on analyzing graphs, a very basic introduction to this topic. This graph is very similar to the one that we looked at in the earlier example, with one exception. You can see here that the end point on the right hand side is an open circle and thus is not included in the domain of the function. Another indication that this is the case, if we look here, the symbol here is just less than rather than less than or equal to. So this point at 5, 9 this time, because of the open circle, is not included in the graph. Other than that, everything is the same. So we're going to go through this quickly. The main point of this again is how we deal with an open circle when that happens to be the highest point, or it could also be the lowest point on the graph. So again, we'll go through these points, and we're going to go quicker than the last time. So we're going to label them now. And we'll start with this point. And it's the same as the last example. So -1, -9. This point here, I think we said it was something like 0.3, -1.8, was it? I can't remember what we said the last time. -0.8. Point here is 3.2, -13.1, and this new point that doesn't, it's the same point, but it doesn't actually belong to the graph this time. It's 5, 9, but we're going to put a little asterisk on that to show that it doesn't actually belong to the graph. So once we have labeled all of those, we can go through the same procedure as we did the last time, simply writing out the absolute max and min, the relative max and min, and then we'll talk about increasing and decreasing parts of the graph at the end. So the absolute max, and this is the only change really. We're going to also see when we look at the increasing intervals that there is a little bit of a change. In a case like this, there is no absolute maximum because the highest point is an open circle. And therefore, it's not technically part of this function at all. Okay. Now, the other points that we're going to talk about are the same as they were previously. So the absolute maximum is the one that is most important in this example. So we'll speed quickly through the rest of this. The absolute minimum is -13.1 at x equals 3.2. The relative maximum is -0.8 at x equals 0.3, and the relative minimum, the bottom of the valley, remember, is -13.1 at x equals 3.2. The bottom of the valley, again, is the lowest point on the graph, so it's also the absolute minimum. And that may or may not be the case. It's not necessarily going to be the case that the relative minimum is always the absolute minimum, but you can see that it can be as well. Okay, the one other thing we're going to talk about here is we're going to look at places where the graph is increasing and decreasing. So we'll talk about increasing because that's the one that's slightly different. Okay, so remember, for increasing we're going to use x coordinates. Okay, increasing and decreasing, both use x coordinates. Well, this graph begins here and it increases in that interval. So the x's here go from -1 to 0.3. So we can write down -1 is less than or equal to x is less than or equal to 0.3. And in that case, just like in the previous example, it doesn't matter whether we use less than or equal to. Again, the graph increases from an x of 3.2 up to an x equals 5, but it doesn't include the x equals 5, and this is where this example is different from the previous one. This interval begins at 3.2 with your x being equal to 3.2, so we can go with less than or equal to. And now this is the only point that we've seen where the inequality sign is important. We cannot use less than or equal to 5 in this case. We have to go with x less than 5. The reason being that x equals 5 is outside the domain. The domain is strictly less than 5, and therefore we don't have a choice in this instance. We have to go with x being less than 5. Okay, again, just like we did in the previous example, join those with the union sign. We can look as well at where this graph is decreasing, but there is nothing new in the decreasing part of this, so we'll just do it here. So there's nothing new there, but we'll just, for the sake of completion, finish it off. So the graph begins decreasing when x is 0.3. It's less than or equal to x is less than or equal to 3.2. So the only time in which you're forced to use a less than sign rather than a less than or equal to is if you're talking about an end point that is an open circle. If you have an end point that is an open circle, the interval sign must be less than. Okay? Good luck. Thank you.